Hello and welcome to Empowered Learning. This video will be about evaluating algebraic expressions. So when we start to move from the mathematics and where we're just dealing with numbers to where we're dealing with letters and numbers, as many people say, we have to be able to identify what the difference in between an expression is versus an equation. And so the first part of that is knowing what an expression is and what the components of an expression are. So the first thing that we want to talk about is a variable. So a variable is a letter to represent all the numbers fitting a particular pattern. So as an example here, when we have an expression 2x minus 3, the x is just a placeholder saying that any number that I'm allowing myself to plug in there could be put in this particular spot. So that is what the variable is. So variables are just placeholders to represent a lot of different kind of numbers that can go into there at one time. An algebraic expression is a collection of numbers, variables, operation symbols, and/or grouping symbols. And so as an example here, 2x minus 3 is an algebraic expression. It is a two-term algebraic expression where the first term is 2x and the second term is minus 3. Okay, and of course we're saying that because I could rewrite this way. Now, whenever we evaluate an expression, what we actually do is we replace a variable in an expression by a number and then find out the value or the result of that. So for instance, if I wanted to say x was equal to 1 here, then when I evaluate this expression when x is 1, I would just put 1 in place of the placeholder, and then from there I would evaluate this. And of course from that point, then we're using what we know as far as order of operations and such. And if you have not checked out my order of operations video, and you need to, go ahead and check that out as well. So if we do this, we know that 2 times 1 is 2. And then we know that 2 minus 3 is going to be a negative 1. So that is what we mean when we actually evaluate an expression. So let's look at some more examples. So we see here, we have the expression 7 plus 3z. And we want to evaluate that expression if we allow z to equal negative 3. So do you see how the z is just acting as a placeholder, and once we figure out exactly what we want to put into it, we just put it there, and then we follow our order of operations to be able to evaluate the expression for the exact result. And of course, with the order of operations, we have addition and we have multiplication. We know we have to do multiplication first, so that's how we get the minus 9 here. And of course, 7 plus a negative 9 is the same as saying 7 minus 9. And so you can think of this as you have $7 in your pocket, but you have $9 that you owe someone because you need to pay a bill. And so since you don't have enough money, that's why once you give him or her the $7, you're still short $2. Okay. All right. So let's evaluate the following expressions for the given values. So we have this expression here, and we want to evaluate it when x is negative 1 and y is 3. So if we do that, then we know that in place of y, we're going to put 3. And then in place of x, we're going to put a negative 1. And notice that we're doing parentheses around there because we know that we're taking some value there and squaring it. So we want to be very clear on what it is that we're actually squaring. Now, according to our order of operation, we know that we have to do the negative 1 quantity squared first. And so 3 minus negative 1 squared is just 1. And so our final answer is 2. For our second example, we see that our expression here is gh minus h squared. And we're allowing g to be 0, h to be negative 4. And just like how we did earlier, we just take those values that we were told to represent the variable or the placeholder, and we just plug them in. Okay. Saying evaluate is the proper way to say it, but sometimes we just say plug it in so that we can sort of understand what we're doing here. All right, so once that's gone, we know that 0 times anything is 0, so that's how we get 0 here. We write our minus sign, and then we know that -4 squared is the same as -4 times -4, which is a positive 16. And so then from here, we just translate that to be 0 minus 16, and we drop the grouping symbols here because there's nothing else left for us to do inside of it. And of course, that is why our answer here is -16. So let's move on to our next example. All right, so now we see that our expression this time is going to be a minus b squared. And of course, we let a be 2, b be -5. So in place of a, we just put the 2. In place of b, we put the -5. And of course, we know we have to do the exponents first according to order of operation. -5 squared is 25. And of course, we write the 2 and the minus there. Please do not get confused and think that in this case you have to do subtract the negative number is addition. That is not correct. The reason why it is not correct is because we have to complete the square operation first before we do anything else. And so to make my point clear here, if we would have had a situation like this, since we're not squaring anything, then this -5 has nothing else that needs to be done with it. And so at that point, then we could say subtract the negative number is the same as addition and say that the answer is 7. But since we have this exponent here, we have to multiply -5 times itself first. And then after that, do the 2 minus and add that to the problem. Okay? All right, so let me get rid of this. And let's go to the next example. So now we have what's called a quadratic expression here, where the highest exponent on any variable is a 2. But for us, it's still the same thing. We take -3, plug it in for x here, or replace it with x. And then here we have minus, and then we have a -3. So notice that the minus came, and then for x, x on its own is -3. Okay? And the same thing here. X on its own is -3. So that's why we're putting the parenthesis around. And then, of course, we do the add 2. So -3 squared is -3 times -3, which is a positive 9. Then we write the minus. And then we'll do the -3 like this, plus 2. Now, we know that subtract a negative is the same thing as addition. So we'll make that addition, and now we'll say 9 plus 3 is 12, and 12 plus 2 is 14. All right, so looking at our next example, example E. We see that this is our expression, so we just substitute in what y is, and z is 0. So of course, -5 squared is a positive 25 minus -5 squared is a positive 25 times 0. And of course, 25 times 0 is just going to be 0. And 25 minus 0 is just 25. For our last example, you see that this is our expression. So x is a -3 minus 4 times -4 is what our y is, plus z is 8. And of course, we don't have to put parentheses around that because we don't have anything else with it on that term. So from here, 2 times a -3 is a -6. Here we see that negative 4 times a negative 4 is a positive 16. And we do plus 8. And then from that point, we just go from left to right. So negative 6 plus 16 is a positive 10. And 10 plus 8 is 18. That's our final answer. So this concludes the lesson on evaluating algebraic expressions. Hope this helps. Take care.